This is killer indexer puzzle I designed using some new constraints. For the rules, we have normal Sudoku rules. Every row, column, and 3x3 box must contain all the digits from 1 to 9. Then we have killer cages, so the sum in the cage cannot repeat, so these two must be different. And the sum must equal the total given in the upper left corner, 12, 18, and so on. And then cages also form a sequence, one way or the other, reading from one end to the other, or the other, doesn't matter, but it forms a row, column, and value indexer in one way or the other, and their difference must be the same. So the difference between these two is the same as the difference between these two. And two cage, let's say this cage of 12 might refer to some cell here, but another cage, this one, cannot refer to the same cage, same cell. So the referred cell would have to be unique for the cage. And well, this is row column value, so if it were, let's say, well, it can't be 1, 2, 1, 3, 5, but this is the example I take, so 1, 3, 5. It could be, so in column 3, row 1, we could place a 5. Well, I can't do it if it were here. We could place a 5, or in column 3, row 5, we could place a 1. So the reading order is not fixed, but the cell itself must be the single one reference for the cage. And then, well, to avoid a deadly pattern, there's a white dot here, so these two cells are consecutive, these two values. And that's for the rules. Now, because there is the same difference, indeed, this is the overall sum of, let's say the middle digit is n, then there is a difference of n plus something, 1 or 2, and here a difference of n minus 1 or 2, so the same difference between these two, which means overall this is 3 times n, and whichever the way we read it, we know that the middle digit is 1/3 the average, which is 1/3 n. So for the cage of 12, this is a 4 and 4. All cages are multiple of 3, of course, so 18 is 3 times 6, 3 times 6, 15, 3 times 5, and 21, 3 times 7. Now here, this cage of 18, well, it can't have a 4. It could be 3, 9 or 5, 7. This cage here can contain 6. It's the 1, 7 or 3 5. On 7 or 3 5, which means that this one cannot be 5 nor 7. It would leave nothing for this cage. So this is 3 9, and now there's no 3, so it can't be 3 4 5, but 1 4 7. And we know the order here already. Now for these two cages it's the same sum. So this is 1 7 and 3 9 here, leaving 2 5 8. No 5 here. So now we have two cages, 1 4 7. They cannot refer to the same cell. So it means that in row 4, in column 1, we may have a 7, or in column 7, row 7, not this one, but this one, this is 7, we may have a 1. And these are the only two possible combinations for these. So we must have a 7 here for one of the cage and a 1 here. It doesn't matter which cage refer to which cell. It is not part of the unique solution, but we know that these two are referenced by these two cells, these two cages. We leave it like this. The same with 3 6 9. So in column 6, location 3 and 9. In 3 we have a 9, or in row 9 we may have a 3. So 3 6 9, and the same logic, they can't refer to the same cell, so they must contain a 9 there and 3 here, and so these are the cage. So this fixes the 3 and the 9. And then, so what do we have here? 3 goes here. This is 2 5 8. 1 goes here. 2 5 8. There's no 5. So the 5 goes here for the row. Now we may, so we can think of these 3 cages of 15, which must refer to 3 different cells. 15, we still need 10, so it can't be 1, so it could be 1 9, so 9 there doesn't work, and 1 there doesn't work either. So it can't, none of these can be 1 9. 8 2 would work, but not for this one, because it would be something. So 8 2 could go there, and then we have 3 7, so 7 3 3 won't work, and 4 6. Well, this can't be 2 8 because it would place 2 8 here and leaving nothing for this cell, and can't be 1 9 no 3 7, so it must be 4 6. These are the only 3 possible combinations. So we must have, like for these, we must have both 2 and 8 here. So this is 8, 2, which fix some 2, 8 here. And then what do we have here? 4 and 6. But first we might think about this one. It means that in column 5, row 4 or 6, we place a 4 or 6. It can't be there, so we can't place a 6 there in row 4. But we must place a 4 in row 6, and this is a self-reference cell. So this gauge says that row 6 column 5 we place a 4, which is itself. So let's give it this color. Like this, to be consistent, and 2 5 8. Let's give them another color. Let's say orange. So this is 4 6, and then I guess 3 3 3. And then 8 9, so 8 9. 8 8. So 8 goes here, which fixes this gauge of 21. It must be 6 7 8. Which tell us that in column 7 and the row 6 on row 8, and in row 6 we place 8, it can't work, or in row 8 we place a 6. So it must be this can be 6 5, so this 6 7 7 here. And then what do we have? 5, 8, no, 4 and 6. And then we have 3 and 9. Maybe I should check for 5s. Yes, there's a 5 there. And then here, 2, we have quite some 2. So 2. 2 here. here and here. Six maybe, yes. It's all the sixes. 7. Can't tell yet. What we know, this is C1. 7, 9. The 3 goes here. This is 3 or 9 again. Polygon. Here we have 1, 4 and 9. Which gives 3, then 9, and 3, 1 more 4, 1 more 4, so this is 4, 1, no, it's only regular Sudoku, so 1, 9, 7, 9, 3, 7, 4, 4, 3, 7. Here we have 4 and 7. 7, which gives 3 and 1 to finish the puzzle, and that's it. I think it's not too hard because you very soon have digits placed. Maybe this is a bit more tricky for the 15, but for the rest I think it's not too hard to discover. So that's it.